Okay, let's get started. Okay, yesterday we got to the point where we had basically reintegrating. I realized that after I'd done it that I'd already integrated it once, but anyway, reintegrating the uh, the dependency injection. I'm calling it dependency injection, but it's not really dependency injection. Long story short, reintegrating the thingy that handles my dependencies into the main project, and I was having some trouble with the name resolution. It turns out that I had inadvertently done this, and when you do that, that obscures the package name. Okay. You know, you have those moments where you're kind of like doing something and you're like, oh, duh. Um, anyway, I had that moment yesterday. Anyway, long story short, um, here's an example of using this kind of dependency management thing. So let's go ahead and close this to give us more room. So I register a timeout value of 15 seconds, and then I register a function to get me a connection from a pool. Now, the way I get my pool is it is a closure. So the pool is connected up here, and I just reference it here in this code, and I'll have that in the scope of my function, so I'll have a closure over that. In this case, I get the duration, and if it's a duration, if there's any problem getting the duration, I set it to 15 seconds. And I create a cancel timeout context, and I go ahead and acquire the connection and return back a new DB caller with that connection. So what this does is it gets me back, for the purposes of my application, a new database connection every time I ask the dependency management system for something called caller. All right. So now file service is a little bit higher concept. So file service references a caller. So I go ahead and grab a caller. If I can't, for any reason, if this for some reason can't be cast to a DB caller, and that shouldn't be a problem, I go ahead and return a nil false, start generating errors. But I build a new file service from the caller, and that is when I make a request for something called a file service from the dependency injection. Or I really don't think of it as dependency injection. It's more like a dependency builder or something. I don't know. Metadata service, same thing. It's built using a caller, so it'll pull a caller out. And again, every time I ask for something called caller, I'm executing this function which builds me a new DB caller with a connection that I have freshly acquired from the connection pool. And finally, I have an image repository. Now, an image repository doesn't directly depend on caller, it depends on the metadata service. So it grabs a metadata service. The metadata service is in turn calling the caller. So by the time this thing returns back to me, I have a metadata service that contains the reference of the caller, but I return back an image repository. So I have an increasingly higher level concept, and it's based on building me what I need at the time from these values. Now in this case I'm using a lot of functions. Here I register a simple value. Here I'm using a lot of functions as builders. But it's the same concept. I'm basically saying I don't care how I get this, I just want a caller. I don't care how I get this, I just want an image repository. And we can start moving this to, let's start moving this to a configuration function. And what we do want to do is we want to move this is what I want to get back to. So here is one approach that I'm considering. So except our global reflex would be, well, no, global reflex is handled by reflex. So reflex, when I grab the global reflex, what I'm doing is a one-time initialization of the global reflex, but then I'm just returning this value. So from here on in, I'm returning this value. Now, one of the problems is this really isn't safe for concurrent access. 99% of the time, all my initialization will happen in my main function. So let's do func init. Let's say init system. And we will pass it a pool. And it's a reference to a pool. You can take all this good stuff. So okay, we've got it up here in init system. So 99% of the time, we'll call init system once, and then from there on in, we will call, we'll be calling these methods from multiple Go routines probably, because we'll run this in the context of a web application. And so the only thing we need to really worry about, like if we call caller, because the rest of this is, these are all, like if you look at these are all local variables, right? So caller, okay, that's local, that is on the stack, it's not shared, and it's returning a new value. It does wind up looking into the two maps here that we have here, but we're doing a read-only access, so that should be fine. The only thing that can get us into trouble is if two things try to go through acquire at the same time. So let's double check the documentation for acquire. And acquire, let's take a look at acquire here. So there's a inner P, and yeah, feel free to make jokes about that. So here's a puddle pool. So yeah, as long as let's see if we can find it on the PGX site. Oh, that's just looking in my cloned repos. Okay. And if we go in a PGX, well, that'll just give us source code. What we really want to do is go take a look at the documents. Connection pool. So it says the connection pool is concurrency safe. And let's go to PGX pool. And let's take a look at acquire. Nope, that just got us back here. Type pool. Well, from the other comment, we read that it is supposed to be concurrency safe. But, you know, it pays to do your diligence, right? But we could use my other option to make this totally safe, right? So we could have a separate Go routine that basically fields requests for things. So I send it a request for a caller, and that is sent. That request is sent via channel to a Go routine, which does the work of building the caller and returns back to me a caller through a channel. And the upside of this is we don't have to worry about the thread safety of Reflex, because it will be, there will only be one thread going through the Reflex code at any time in that one Go routine, whereas now multiple things could go through that code at the same time. I'm not too worried about it unless you're in the habit of re-registering values periodically, in which case it's not thread safe. So there is some justification putting in a Go routine. Other justification for just saying, you know, it's not thread safe, initialize and then use. So we have data, right? We have our metadata service, we have our model, which is our image repository, but that's not what we talk to. So this has been a very long-winded journey to get back to building a querying interface for my API, and that involves thinking about my service interface. So, oh, I know you're groaning when I say this, but let's go take a quick look at the layer cake, and let's take a look at where we are. Fantastic. Like, he has only one drawing he's ever done with this tool, and that is this. That's not true. I just have one drawing on this machine that I've ever done with this tool. This is actually one of my favorite diagramming tools ever. So now I'm going to talk about the service interface layer, and so I got my model layer, got my data access layer, got my database. Now what's my service? My service, let's think about this for a second. What do I want my service to be able to do? So let's new layer. And just like these are their own modules, we will open up a terminal, drop into service. Okay. Okay, so all right, so I will actually move it into its own file because I'm not going to have everything in one file called service for all my different service endpoints. But this endpoint is for the file service, and so what should we have? We should have a get on something like file, and that should produce something like files, and that should produce a list of available files. Get files, and you know, I heard recently that there's shouldn't say I heard. You know, one of the wonderful things about common wisdom is that nobody questions it, right? Um, and if you do question it, you're a loon, and no one takes you seriously. But for a long time, we've done APIs like files 23, and that the contents of file 23. For a long time, we've done things like that, right? And get files 23 authors 7. Get info about right. So we know from our the patterns that we stick in front of our handlers and stuff that this refers to an ID of an author, this refers to an ID of a file, and that's great. And we parse out the URI. Wait a minute, we're parsing out the URI. So the system does it for us, but we've already, I mean, in a sense, this is really no better than files. So this is no more unique than this. And recently, the fact that we've built kind of, this crazy world of this kind of stuff, like, this is a little bit extreme, but you get the idea, is we've got these things that are just kind of unintelligible, right? So this is intelligible. This is mostly intelligible. This is garbage, right? So there's been some kind of movement back to, URIs had a built-in system in the in the query parameters section of the URI to basically pass values, right? So we've got files. So that gets us file 23. So I'm not sure which I want to use, but let me say this. At this level, I shouldn't care. At this level, this is something I do when I'm picking apart the request from the web server. But at the layer of defining my service, what does it mean when somebody asks me for a file of a given ID? I shouldn't care about this format. But just be aware that that this is really not any better than this. Okay. But we will go with this for lack of a better, because they are equivalent, for lack of a better option. We'll go with this for now. And when we hook this into a web service, we will make a decision about it, but just not now. So now we're just going to talk about the raw service interface. So if we get files, and we'll even say with an ID of 23, we get the image data for file 23. And here's where we hit another point where I'm not happy, is I don't like to expose that number. So I have in my model, need to start Postgres. I have in my model an ID, right? But I don't. These IDs in my database model are not meant for public consumption. They're meant to relate metadata with a locator. And encoding information. So these are really not meant to hand out to people for permanent links. If I do that, I am locking, think about this for a second. If I do that, oh man, close the damn picture. If I expose those IDs, I'm basically locking this layer to the database layer. I'm creating I'm just plowing right through all my other abstraction and linking my external world to my completely and totally internal world. And I do not want to do that, right? So I'm missing an abstraction. I'm missing the ability to have some identifier as being the permanent link or permalink, as you can see where I'm going with this already, I think. So get files with a permalink of 23, and I get the image data for 23. This implies that list of available files. So when I get the list of available files, I want the file name, sources, encodings, and permanent links, right? So actually, this doesn't exist, right? So get files with a permalink of 23 doesn't make any sense until we've built a permalink, right? Which implies this. Each encoding has a unique permalink, right? So if I want to get files with a permalink of 23, the image data for file 23 means that each encoding get files So this makes sense, right? The first one makes sense. I want a catalog of all my files. So this loose, so I expect this to return something like, you know, there is no individual file name. See what happens when I step away for a little bit? So this is so this is the metadata features. Encodings. And I don't think we need locators at this point, but maybe, okay, so we want, what do we want? We want, out of the metadata, we want date captured, so from the metadata we want the date captured, location, and tags. That's, we definitely want that. From encodings, what do we want? From encodings, we want runtime, which is optional, resolution, MIME, type, and from locators, we want source path. Well, we want source at least, right? So that together represents an individual file. Note that I didn't say file name. I took out file name because I really don't have that concept, because I could have a file at the end of an API, and so I might have its API information but not necessarily its name captured yet. So that's what I get on my list of files. Um, so I would like at some point to be able to pull back the image data. And so get locators. So if I do a get on locators with a permalink of 45, what do I get? I get the locator. So if I get the locator, source, and path, right? Or URI or whatever it is. But I get the locator. Um, I think we call that location. And we'll say its name is locations. Okay, so we have get files, returns metadata, returns an encoding, and returns locators. So we could have like a wedding picture. It's got two encodings, a JPEG and a thumbnail. And the location for the JPEG are two locations, and the thumbnail is one. Really what we're looking at here is an image with a location permalink of 45. And this looks up the file based on the location to get back the file data, right? So if we get image, so from a service standpoint, this lists the files. And the files we have, because again, this is about bringing structure to an unstructured collection of images and other assets, is we have all these likely candidates for being a thing. And then if we want to get back an image, we need to ask for a specific piece of data. And the thing that points to a specific piece of data is the locator. So that means this needs a permalink. Okay. So what's a permalink? It is a missing abstraction down at the data layer. Well, it's not missing abstraction at the layer. It is a missing concept at this point. it is a fabricated so where would the permalink sit? Again, I closed it. Why do I do that? And get rid of this. Okay. So where does permalink sit? So here we're returning a URI with a permalink, right? Here we're dereferencing the dereferencing a permalink to a model. Here we are dereferencing the model This is dereferencing the model to a data element, and this finally is a database request. And down here we have permalink. So why is this better than just returning the locator ID as a permalink? Well, again, I may choose to have a different implementation, in which case it doesn't make sense to have permalinks that, or doesn't make sense to expose URIs that are tied to my database layer implementation. So a permalink, unlike the ID that happens to be in the current data model for encoding, or I'm sorry, a locator. So this happens to be an ID, it happens to be a big int right now, it could change in the future. So rather than tying it to my locator ID, I'm creating a thing that's meant to represent a hook to that data in the real world, or in the outside world. I want to wrap it up here, but I think just talking through this, and keep in mind when I'm doing this, I'm just talking through stuff in my own head. I haven't made the decision on a lot of this stuff, so I'm working through it, and I'm doing it in front of you because hopefully that'll let you know that we all have to think this stuff through. We don't magically know any of this, and we all have to examine our if we're going to do a good job at this stuff, we have to examine our implicit beliefs and our understanding of the problem, and hold it up to scrutiny to see if in fact we do have good understanding of the problem. So anyway, long story short, Don. Long story short, at the end of the day, the permalink is designed to be that bridge so that, let's say for example, the permalink looks like ABC123, right? Some generated, so this brings us back, locator, so this brings us back to this brings us potentially back to an image model, right? Then this brings us down to so that as we pull on down to an element, we're talking about a locator, and we're so what could happen is we could decide that we're no longer going to have we're going to store images in some other manner, and so permalink 123 doesn't change. The person with the URI to an image ABC123, that stays, that keeps responding with data, but the underlying implementation's totally changed, and the outside world shouldn't care. The reason I'm actually looking at this problem is this is something I've run into in the real world, where we have some way or some organization of the data on the back end, which makes perfect sense for the way the data is physically stored on the back end, but that's not necessarily the interface we want to present to the outside world. We want to present to the outside world a kind of, keep in mind, a lot of software is about presenting a fiction that we want the world to believe about us. And it's not necessarily the truth of the underlying system. So the underlying system is composed of files on a file system, and they have duplicates, and they have various versions of the image, and we might have archival quality versions, etc., etc. But we want people to be able to say, hey, I want my picture of Uncle Sal at the beach, and so I want ABC, ID ABC123, and if we wind up totally ripping this out and replacing it with something else, Uncle Sal at the beach is still ABC123. And in the past, that's meant keeping around, when I've run into this problem in the past, that means keeping around things that don't belong there anymore, just so you can make your URIs work. Or conversely, you just go ahead and return a 404, and suddenly, somebody's bookmarks all just suddenly go, are just worthless. So I would recommend thinking about the abstractions that you want to present to the outside world, and building something that presents that abstraction, but not necessarily making that a mirror of your underlying physical world, because if you do that, you're trapping your physical world and the kind of presentation of your data in the same together, and you don't want to do that. You don't want to lock, you've done so much work to keep all these layers isolated so that they don't intrude on each other, and then to lock the outermost layer down to the innermost layer, just you know, blows the whole thing up. All right, that's my soapbox. I'm done for today, and I gotta go and do that whole work thing.